Hey everybody, this is Penelope Weinberger. I just want to let you know that we're going to get started in a couple minutes. We're going to let people, give them a chance to roll in, and then we're going to turn it all over to Jeremy Aycock to lead us through this webinar. So welcome.
Hi everybody. Welcome to the AASHTO GOTUG webinar. I apologize, I can't get the presentation screen to show up without the notes on my side, but we'll just go ahead and get started. As Penelope said, this webinar will be recorded. This is our second webinar of the year. And before we get started, I just wanted to go over what GOTUG is and what we do. So GOTUG is an AASHTO sponsored user group. The long name is the Geospatial Online Transportation User Group. It began in September 2015 as an AASHTO innovation initiative called UPlan, that was started by Utah DOT. And in 2016, the user group was created as a response to rapidly increasing pace for development of web-based GIS tools and applications. The goals of this group are to bring transportation professionals, GIS, and engineering disciplines together to focus on the use of web-based GIS tools among transportation planners, engineers, and GIS professionals, and to provide a forum to exchange ideas about the future of web-based geospatial tools in transportation. The key people are myself, Jeremy Aycock, I'm the committee chair, and Penelope Weinberger, who is the AASHTO liaison. To round out the steering committee, we have Adrian Sellers with Utah DOT, Andrew Wimsatt with Texas Transportation Institute, Nicole Hansen with Idaho Transportation, and Mark Sarmiento with the Federal Highway Administration. As we said earlier, these webinars are quarterly, and they occur on the first Wednesday of March, June, September, and December at 1 o'clock, and this provides a platform for DOTs and business partners to showcase implementations of web-based GIS tools and to meet business needs. And below you can see a couple of, or a few different themes of webinars that we have posted before. Our past webinars are also available on our GOTUG website, gotugtransportation.org. There you can also sign up for our distribution list and look at our steering committee. Some more AASHTO technical resources. Up top you see the distribution list and the GOTUG website again. If you have any ideas for webinar topics, or if you want to get more involved in our group, you can email gotug@transportation.org. And the idea for these committee resources are to increase the visibility of GIS and geospatial data issues and provide a technical resource group for all AASHTO vendors. Some other transportation GIS related resources. There's an MPO GIS working group website. You don't need to be a member to participate in this group, and they also host webinars, and a list of their most recent webinars are available towards the bottom of the webpage. The Federal Highway Administration and GIS Transportation Program also contains GIS-focused case study reports, peer exchange summary reports, email news briefs, as well as webinars. The next GOTUG webinars that we're having are September 2nd and December 2nd, and we'll be featuring more presentations from GIS T2020 that we missed this year. All right, and without further ado, we will be hosting two presentations today, both focused on data acquisition and dissemination. The first will be creating SIMS, the benefits and challenges of bringing different data sets into one place, with John Zender and Noreen Wilczek from Minnesota DOT. And our second will be Project Atlas, filling the data gaps to improve DOT project delivery, with Eric Wilson. If you have any questions during these webinars presentations, please enter them into the chat on our GoToMeeting bar, and we will answer them after the presentation is over. And without further ado, I will hand the presentation over to Minnesota DOT.
Thanks, Jeremy. Can everyone hear me?
Yes.
Okay, and Noreen will be starting us off.
Yep, just waiting for the, there we go, screen share. All right, can you see the presentation?
Yep.
Looks good.
Okay, great. Thanks, Jeremy. Today, John and I are gonna present on the Minnesota Department of Transportation State of the System Mapping Application. First, I thought a little background would be good, particularly on the purpose of us developing this map and why we thought it was important. Given the magnitude and condition of our current transportation system within Minnesota, but especially within the Twin Cities region, and the fact that all of us work with limited state and federal funding, or our organization regularly seeks out opportunities to collaborate with local and regional partners to try to leverage available resources to advance long-term transportation visions. To do this, we do not only need access to data, about our systems, we also need the ability to share with our local partners. That way we can have a more informed and engaged discussion on these opportunities for improving our system. The map we are going to discuss today really is intended to provide a snapshot perspective of our infrastructure and the investment infrastructure condition and investment needs for transportation corridors in areas within our transportation system. Specifically, this is the Metro District version. So that's the Minneapolis-St. Paul area in Minnesota. There is a group from MnDOT's statewide central office who's working on a version for Greater Minnesota in the following months. So again, the Metro District covers an 8-county area, and you'll see that when we do a map demo of this application. This map has been in development for the past 2 years. It's taken us a while to get here, but we think the time has been worth it. We're working on the final details for going public and hope to go live soon. John and I have spent a great deal of time putting the map together, getting feedback, and we've really learned a lot through the process, which we want to share with you today. Although the map is new, the idea of mapping the information about the highways and infrastructure condition, even safety recommendations, is not. We are just building on work that was previously done. Back in 2012, MnDOT began creating this information, and at the time, they used GIS to get various information, including conditions, recent investments that have been made to the transportation system, and planned and program improvements. On the right hand of the slide, you can see an example of the kind of data that was pulled together for these maps. Once they pulled together this information, they had it separated out by corridors, and they took the information to the public and the local partners to discuss what are some of the needed directions they needed to have on the corridor. Where should they be planning investments? Really, it's just a planning tool. The response from local governments was very positive. They appreciated appreciated having this information available and really created the opportunity to have more informed discussions about the investment needs for our highway system. Although the information was positively received, it was pretty quickly out of date. As you can see on the map we have provided, there's a disclaimer in red at the top that directs the users to the MinMap gallery. It's our online MnDOT gallery. As we realized with our mapping project, it was really a large effort to gather all this data together, specifically to gather it frequently enough to keep all the maps up to date. Since the maps have not been updated, the Metro District really started the effort to update them and add new data. Since 2012, when the maps were originally created, there have been many advancements in GIS technology, specifically with online interactive maps. We made the decision not to update the data in the maps, but to create an entirely new format, one that provided flexibility to quickly update information and to take most of the work out of the update process. The format Metro chose was an interactive story map, which I will discuss now. We were primarily interested in the format that allowed us to present a lot of data in a dynamic way in one place and to internal and external audience. ArcGIS Online offered us an option to do this. MnDOT has multiple interactive maps developed, including an internal-only map viewer called Georilla. Georilla is an open source mapping product that is developed in-house. The limitation, though, with Georilla for this project is the ability to share with our external audiences. Currently, Georilla is only available to view from a MnDOT computer within the enterprise network. With the final version of the Minnesota State of the System developed on the ArcGIS Online platform, we will share the map publicly for all our external partners to view. So as I mentioned earlier, keeping the data up to date is a monumental task. However, with ArcGIS Online, we are better able to switch our data sets to a service-based model, allowing us to better deal with that issue. Our goal for this project was primarily to rely on services that were tied to regularly updated databases, leaving less for us to update in the long run and making the project more manageable. In addition to allowing us to rely on services for our data, the ArcGIS Online format allowed us to display our information in a more interactive way. With ArcGIS Online mapping, users can select the data they want to display easily through pop-ups and clicking on and off certain layers to display. And we've set certain data sets to be viewable only at certain scales, like our bike and pedestrian data, so it's not as clustered as it would be. The online format really allowed us to be creative with the data and provided opportunities for displaying data that weren't previously available in the last iteration of the PDF maps. However, we still had the issue of presenting a great deal of data in one place. In the last iteration of SIMS, we had multiple map themes, such as existing conditions, recent investments, and so on, to provide the whole picture for each corridor. Even with the new interactive format, that's still way too much information to display on one single map. We struggled with this issue for a while, wondering if we should have 4 or 5 separate maps, such as in the previous iteration, for the Metro. However, we still wanted to bring all the maps into one place to show that the data sets were connected. I researched and explained the possible map solutions to our group, and that there were several story map formats available that I thought we could do this with. One of the formats, called the map series, that's the map with the separate tabs across the top, was the ultimate format that we selected. This allowed us to replicate the previous effort and still manage to keep all the data in one place. The way in which platform used to convey the data wasn't the only challenge we encountered by bringing multiple data sets together. Figuring this out was the major step forward in developing the map that we're going to show you today. However, we still encountered a few more challenges along the way, which my colleague John will talk about further in the next slide.
Thank you, Noreen. So once we had decided on using the story map web map series as our overall structure, we still had three major problems with some of our data sets and assembling the data. The first was the issue of disparate data sets. So basically, this was the case where we had one overall transportation topic, but there were certain data sets that may have had different ways of covering the topic. Different data sets that took different perspectives. So for instance, one area that we wanted to include in this that was not in the original SIMS maps was mobility, specifically traffic congestion, because that's something that we thought would be relevant but hadn't really been integrated before. So we can see on the left is an example of our traditional system for measuring congestion with MnDOT. So basically, we have loop detectors that are embedded in the highways to detect vehicle speeds, and roads are considered congested whenever the average traffic speed drops below 45 miles per hour. So the map on the left shows duration of congestion. Whereas on the right, we also want to show congestion for roads that aren't part of the freeway network. So state highways that don't have the same access control and don't have the loop detectors embedded. So for that, we take data, mobile data off of cell phones in order to gauge traveler behavior. So this map shows congestion based on the relative slowdown in speed from the overnight period. So how much does traffic slow down during the peak period from 3 to 7 or from 6 to 10 in the morning? And basically, these maps are both talking about congestion, but they're comparing apples and oranges because one is duration and the other one is intensity. So our solution for this was to have two different tabs in our map just to guarantee that the users would not accidentally conflate these. Because as part of our usability goals, we wanted to make sure that the users were not being confused about what they could and could not compare. So our solution was to have two different tabs. So we can look at another issue in the next slide. So another issue as far as making things as transparent as possible for our users was the fact that we are combining static and service layers. So not everything is a service. There are a few things that are static and don't receive the same frequency of updates. So at one end of the spectrum, we have services, for instance, from the Metropolitan Council about public transportation. Those might include routes or stations, and those are updated as often as weekly. On the other hand, we also have some types of static layers that are maybe one-off studies that are only done once every 5 years. In the middle, we have something like bicycle trails, where our main bicycle trail service gets updated annually. But then we also have an area for Chisago County on the north side of the metro, where they're not part of the Metropolitan Council, and so we have a static bicycle layer made specially just for that area. And so we wanted to make sure that the users had real access to metadata, and this is why metadata is so important, because it tells the user exactly what they're looking at to make sure that our users know exactly how new the information is that they're looking at. So on all of our maps, we have links to metadata PDFs, and I just have a little screenshot of that on this slide, and we'll look at this again later. And so this tells what office is in charge, what the update cycle is. It gives some information about the symbology, and then it also gives some technical information about how the layer was created. And then finally, there is a link to more detailed PDFs if, for instance, the layer was from a larger study. So our goal with this was for users to have the best understanding possible of exactly what they're looking at and that information at their fingertips. So, and also the static versus service issue came up with one last problem with our data, which we can see in the next slide. And that was the fact that we have some data sets that are really a combination of static and service data. So normally in most of the maps, you would think the more up-to-date the data, the better for our users. However, one case where that's not true is in our future pavement conditions. So in one of our maps, we have existing pavement conditions, and in another one, we have projected pavement conditions 10 years down the line. And that is from a computer model that uses as inputs the existing pavement conditions right now, as well as what projects will occur during the intervening years. So where the issue gets to be is that the projects in the intervening years are often changing. The projected projects may change throughout the year. So we have two major project plans. One is called the State Transportation Improvement Program, which is the 5-year plan. That is fairly set, but then there's also the Capital Highway Improvement Plan, the CHIP, and that is a 10-year plan. So it's really an iterative process for developing this plan that we want to project projects based on the current pavement conditions, but then the very fact that those projects are scheduled changes the future conditions, so that comes back in a loop to somewhat influence the projects. So it's really this iterative cycle that happens throughout the year, and this process of refinement where eventually we get to a final plan in October. So our issue with this is that the CHIP and the STIP information for the projects, that can come as a service that is updated frequently, whereas the computer model for the pavement predictions might only be run once a year. So we run into this case where the project data may not line up with what our predictions are, because the predictions were made under different assumptions. So our final solution to this problem is to try to, as best we can, take a snapshot of our system. So this will likely be in October when we update this, and that way we can take a snapshot where our projected pavement conditions line up the best with our current planned projects. And even that, we're not able to make that perfect. As we can see in this example on the right side of the slide, we have an area where the construction year for a CHIP bridge project is given as different from the construction date in the predicted pavement conditions. So even with this, with trying to have a snapshot, sometimes there's a little bit of a misalignment between the most up-to-date set of projects and then what our model had said based on the last time that the model was run. But as best we can, we try to get this lined up with a snapshot, so to speak. So now that's the end of our slide presentation, and now we can take a look at the demo. And Noreen will start us off by looking at our landing page for that.
Thanks, John. All right, so here's the Minnesota Department Transportation State of the System Metro District Story Map application. As I discussed earlier, here's the tabs across the top with the different maps, with the different themes of the data collections. We have an info tab, so as John and I just discussed, there's a disclaimer at the top, again, with the data issue he just described, and there's some other data issues. This is a planning tool, so if an organization did want to make a decision or wanted that actual GIS file, they can go to the layer definition sheet and get that information or ask us for that. But we do have a disclaimer just saying this is specifically for planning. So here's a little blurb about what is the MinSauce, what's the purpose of the map, what's in the map, how to navigate and use the map. And then again, as John described, we have links to the layer definition sheet on each map, on each tab in this application. So the user will be able to click on that and get that information. Since we're not, John and I, we're not producing the data, we're just grabbing it to view. So this is really helpful for users to better understand their data. All right, so we'll take a look at the first map. I'll just describe some of the elements, and then John will go into more detail about the actual data. And give it a second to load here. All right, so each map on the left side will have some information about what's in the map. Again, the click here link, that again goes to that layer definition sheet. On the right side here, there's some widgets. We have the legend, so that's what layers are currently visible. The layer list, which includes layers the user can turn on and off. And there's a bookmark widget, so that will bring the users to certain parts of MnDOT Metro's district. And there's also the option for the user to change the base map. We just initially have the default as a gray base map there's a lot of data, there's a lot of layers in this map. So just in case someone wanted to use aerial imagery or open streets or something, this is provided by Esri, this base map service. So they can click on a different base map if they choose. The only exception to these widgets, when we get to that map, there's a query function that we have in the plan or the recent investments. So with that, John.
Thank you, Noreen. On this map, really our major highlight, you can see the green, yellow, and red lines. So those are the existing pavement conditions. And that's really important to have because that's a data set that's often not readily available for planning purposes. So that was a major goal for us. And for things like that, we can click on them. We have pop-ups. They'll say the route name, the direction. They'll also say when the next coming project is, which gets to be relevant for the future conditions. And one thing you can see as we zoom in is that different layers are set to turn on or off at different zoom levels. And this was one of the data debates we were always having, is really what level of detail to go into. And so with this, the idea is, and the user in the legend can see what's been turned on or what's been turned off. So if something's available, they can always turn it off. But we don't want the data to become overwhelming to the user by having too many things pop up. And so the idea with this is that you can see different things as you zoom in, just to try to sort of keep it tidy and not overwhelming in terms of usability. And yeah, and we can see along with the pavement, those colored dots, those are the bridge conditions. And then besides pavement, this really has a lot of other services that are just useful information to know. We have our own service that we bundled that shows the brown lines of the railroads and the airports. And then we also have some of those services from the Metropolitan Council to show different transportation routes that might be relevant. So now we can move on to the recent investments tab, and Noreen will talk a little bit about that.
Thanks, John. Give this a second to load. So here's our recent investments, which includes the construction projects across the metro in the last 10 years. So initially, when you open the map, when the user does, they'll see the last 3 years. But here I can turn on all the layers, and this is helpful for our external partners to see that really there hasn't been a roadway within the metro that hasn't been touched in the last 10 years. So that's important to know that we're not just spending all the projects and having the projects in one spot. There's also a layer here for state aid projects, which are generally county roads and other city roads, to get information on what the state has also helped provide funding for those projects. So that's the last 4 years. That's another service that a group from MnDOT produces. So we've pulled that in. So this is the map that has the extra widget. So it's the query widget. And we thought this would be useful for users to go ahead and, you know, through the 2015 projects then say they're looking for grade and surface. So it'll highlight the results in green. And then on the right here, we'll give you the list. And if the user just clicks on it, it'll pan to that information, to that project, and give you the description in the pop-up. So that's one of the cool other widgets we have for this. You can remove that result and just go back to the map. One of the other things I forgot to talk about was this inset map here on the bottom right-hand corner. So this is helpful for users to see what they're looking at with regards to the whole state of Minnesota. As you zoom in, this map will zoom in so you know what your extents are, which you're looking at. And if you want to minimize it, you can just minimize it there. So that's a little bit about the project, the recent investments. We'll take a look at planned projects. Again, this is a service produced by another group here at MnDOT. And as John described, there's the STIP, so the 5 years out, and then the CHIP, which is the 10 years out. That's a little more flexible with limits and funding and things. And there's also bridge projects for, again, that 5 years out, the STIP, and then the 10 years out CHIP. So this is actually a statewide data set, but again, we're primarily focused with the metro. So a user can click on the project, get that project number, year of construction, and then the description about it. And here's a bridge. See, in some of these CHIP that they're 10 years out, they don't have a project number yet. They're just kind of planned. They're not actually programmed. So we thought that was helpful so the user can compare, you know, recent investments versus the planned projects and get that information all in this application. All right, so I will let John talk about the future needs map.
Thank you, Noreen. And our future needs map is a combination of what things may look like in the future, as well as different studies regarding potential future projects. So we'll let this come up. So once again, one of our main highlights with this is the pavement data. So in contrast to before, this pavement data is the predicted pavement data. And so the idea is really with these pop-ups just to sort of tell the story of how we got here as things stand now. So we have what the pavement condition was, what the upcoming projects are, what the project will be in terms of type, and then finally what rating that will lead to in 2029. So as far as like a planning and public outreach tool, the idea of this is just to be able to say, well, hey, with sort of our current funding conditions, this is what your roads are going to look like 10 years from now. And then we can see some of the things like the diamonds and then the kind of the blue halos. Those represent different features from our different studies, our studies for potential improvements. And we can see, so this one is the CMSP, that's the Congestion Management and Safety Plan. And so that is different things that are sort of spot improvements that we have projected that we could do to improve congestion or safety in certain places. And what's trying to load right now is we have a link, a URL link, and that just links the map user to a document with more information about that project so that they can read more in depth about that if they would like. And then as far as future projects, the diamonds are from the Principal Arterial Intersection Conversion Study. And so those are places where it has been, where there's studying that has been done about whether or not those would be good candidates to turn into grade separated interchanges. And then with these dotted lines, these are our future MinPass program. So the MinPass is what we call our hot lane program, so the carpool lanes. And so these are places where we are planning on adding more of those in the future. And then we also do have some information about, oh, and those are CMSP again, but those areas are where the CMSP project is for more of a corridor rather than just a single spot. And yeah, and then we also have a little bit of information. We have some, oh, and this is useful too, as far as for users to see who they could contact about projects. We have a layer with the different area zones. So that's really part of MnDOT's management system for how we manage projects, and we give the names of the people that users could contact about those different areas. And then we also have we have plans for bike trails, and we also have plans for future transit stations, future transitway alignments, all of those different types of future plans that we have brought together in one place for our map users. Those are planned bicycle system and planned transit stations. And one interesting thing we have with this is the RBTN bicycle system is a little bit unusual as far as plans go. So that was based on a study of really where the routes should go. So for some of those, the routes have already been decided, and we have lines like the kind of magenta lines that we can see now. But for other areas, there are that it's a corridor has been identified as being in need of bicycle pedestrian facilities, but the exact alignment was not targeted by the study. And so for those areas, we have sort of these green or magenta corridors that can be turned on and off. And one thing to keep in mind with that is that in some cases, that RBTN layer has some overlap with the existing bicycle system, because there are places where some municipalities have already built out the alignments from that study, because that study is really just a theoretical model of where the alignments should be rather than where they exist or are planned. And so then finally, our last two tabs are our, where we'll move to now, are our mobility tabs. So the first one is freeway mobility and volume. So with this one, like we saw in the slide, we have the congestion layer that shows the number of hours of congestion on the freeway. We have that either for morning, afternoon, or the combined for the day, and you can click on that and see how long it lasts. Behind that, we have the average annual daily traffic. So that is the volume for all vehicles. That was something that we thought was relevant, so people can kind of see the vehicle volume versus where the congestion is. And then, we have our route information with that. And then this layer is a little bit different, that this is the average annual daily traffic, but just for commercial vehicles. And we thought that was another useful thing for users to see. And the interesting thing is that the relative volume levels are kind of in different places for commercial traffic. We can see really the commercial traffic is relatively heavier on the 494 Ring Road, whereas specifically on the St. Paul side of the metro in the east, commercial traffic of a certain size is not allowed to drive on I-35E, and so there's a lot more of the commercial traffic kind of bypassing around the edge. And then we can see down the pink layer showing certain neighborhoods highlighted. That is the job and activity centers. That is developed by the Metropolitan Council, and that shows areas with at least concentrations of at least 1,000 jobs at a density of 10 jobs per acre, or places that have at least 1,000 jobs that are high concentrations of manufacturing and distribution. So this was just another thing that we thought would be useful for our users to see, okay, these are the places where the traffic is going. So these are the places where there is congestion because people are trying to reach these important areas. And then finally, on our last one, on our non-freeway mobility and volume, This has the same AADT layer for the volume for all traffic, and then for commercial traffic, it has the job and activity centers, but then for the congestion, it is just the non-freeway, so our non-freeway arterial highways, and this shows the red areas, the traffic slows down more during the afternoon compared to what the free flow period would be. And so we wanted to keep this separate just to make sure that people are not trying to directly compare this measure with our traditional measure. And I think that's about all we have with our demo. So now we can have questions if anyone has questions.
So let me remind you to go ahead and type your questions into the chat pane. If you type them into the question pane, we'll probably find them there too. But I'm sure that the 43 people that are on the webinar, someone must have some questions. Here is one question. Can any of your service layers be accessed by other mapping applications?
Yes, so some of those are just internal to our system, but all of the ones that we get from Minnesota's GIS clearinghouse called MinGeo are available and can be used by other applications. And so if Noreen, I think Noreen can show us the site for those.
Sure. This is the Minnesota Geospatial Commons. So this is a great resource for users in the state of Minnesota to search for GIS layers so that we're not just having a bunch of shape files floating around. So we can use consistent data. So if you click on the resources here, there's multiple state agencies, counties, transportation, planning. You can see Dakota County, Pollution Control, Agricultural Department, Metro GIS. There's 883 resources, so that's different layers of data. But if you type in transit, there's 65 resources for that. So, you know, they're available in the map server, so that's the service layers, or at least you can download a shape file or a file geodatabase. So this is where we got many use the services for many of the transit layers that are in our existing and future needs maps.
Okay, here's another question. Are you using a specific standard for metadata? Can the template that you are using be shared?
I think we can definitely share our template that we're using for our PDFs. Noreen, did we just sort of, where did we get our structure for that template? I know that was something that our other group member who could not be here today, Jennifer Wilchin, she originally got that going.
I believe it's a template, and on our end, so we're sharing this PDF with these, 7 columns. On our end, we have a lot more information of who acquired it on our team, either John, Jennifer, or myself, and when we did, who we exactly talked to. So there's even more metadata behind these layers than what the user is seeing, just to protect some of those sensitive fields. But yeah, this is kind of the general layout for our metadata and for the state. If we want to share it, please reach out and send us an email. And
Is your contact information at the end of the slides?
It is, yes. Both of
Great.
John's email and my email are both on there. So feel free to send it to us both, and we'll get in contact with you.
So you can capture that when that goes past, or when the webinar is finished and the recording is sealed up. We'll have the presentations posted to the gotug.transportation.org webpage together with a recording of the webinar. There's a comment, great job on this map, so much information in one place. So thank you for that. And then how can the public access this tool?
So right now the map isn't published to the public yet, but it will be. So this is how users can get to our information. So here's the Minnesota Department of Transportation .state.mn.us, our website. And on the bottom here, there's a link for maps. And as I discussed, MnDOT produces a lot of mapping products. And so our map is under this MinMap, so supported by Esri. So this is our ArcGIS Online site. And there's a gallery of these maps, different mapping applications, and the MinSauce Metro application will be shown under here. So that this is how users will be able to get to our maps, and then of course they can bookmark it when they like it or want to use it again. But yeah, there's a plethora of online maps in this format. So.
All right, here's one more question. What projection is your data in? And if the projection needed to be changed, could it be?
Generally for MnDOT data, we use the UTM 15 projection. I guess if it had to be reprojected, we could, but our standard with most of our data, yeah, we use UTM 15.
All right.
Meters.
Looking, and I don't see any more questions. So thank you very much. Of course, if you have any questions further than this, you can always email them to gotug@transportation.org and or gotug@astro.org actually is our webmail address. And it's in Jeremy's presentation. So I think we're going to switch back to Jeremy now, and he's going to introduce our next speaker. Jeremy, I think you're on mute.
Thanks, I was. So our next presenter is Eric Wilson with NCDIT. Eric Wilson is a GIS project team lead for Project Atlas with the NCDIT Transportation Department. He holds a bachelor's and master's degree from Towson University and is currently working in the GIS unit, continue to develop and maintain Project Atlas, an enterprise system that supports road project development. Over the last 20 years, he has held positions in public and private sectors that focus on GIS project management, GIS application development, GIS data analytics, and GIS development and production. And without further ado, I will give it over to Eric.
Thank you, Jeremy. Can you all see my screen okay?
Yep.
Okay, great. Like Jeremy said, my name is Eric Wilson. It's a pleasure to be here today to talk to you about some of the challenges we face here at the DOT, especially in regards to improving project delivery and some of the data that we are in need of and why it's important and how that plays in. My role is the Project Atlas team lead, and that's a little bit cryptic. So what's important about that is that Atlas is an acronym. It stands for Advancing Transportation Through Linkages, Automation, and Screening. And essentially what that means is that we support project delivery transportation projects through the use of GIS and the surrounding modifications of business processes. If you're curious about what project delivery looks like at NCDOT, it's probably a lot like what y'all are familiar with. We start with planning. Once the early on work is done in the local municipalities or with the DOT itself, to determine they need to actually do some work like widen or add a road, we will go through the prioritization and programming phase, which is to figure out how we're going to fit it into the budget, actually establish some sort of budget for it. Then we move into project development. And project development, along with construction, is where the most of the money is spent on projects in regards to seeing the project through the whole entire process. So in project development, you're basically coming out on the other side with your environmental document, and that includes both human and natural impacts. And so there's a lot of evaluation of data that occurs in there. And it's a lot of a lot of times the place where a project will get held up early on in terms of either obstacles they encounter, things they need to negotiate, and a lot of data fits in to that world. Once we get through the project development phase, we'll move into design, which is where the engineers kind of take over and actually execute the vision and get something more concrete down. And then we go through right-of-way acquisition, construction, and then finally onto maintenance. The vision for Project Atlas and this support of the project delivery process came through a vision that we had in our previous Secretary of Transportation, Jim Trogdon. He basically laid out 8 priorities, and we fit into the lead one there in green. And basically, we were to streamline project development by utilizing GIS tools and data. So we went through a large effort to acquire a lot of reference data for how projects will get developed, and this includes data that comes from federal agencies, local agencies, municipals, the state itself, the GIS unit that I work within. All these different places provide data that is supportive of the project development process. And so we were able to catalog that data, create new data, and we were able to build a pretty cool system. This system basically supports 2 steps in the project delivery process. I mentioned step 3, which is project development and environmental analysis, where the project is funded and the environmental documents completed. But that data that we use to support that effort actually can be utilized backwards in the process for projects that are just starting out for planning purposes. So we see a lot of our applications data and the catalog that we maintain getting used early on now in the planning process as well. And it's really helpful because the data that's used in the planning process, if it's the same data sets that we have referenced as being authoritative, when the project moves through to the development phase, there's not really a lot of surprises in terms of what could be happening in that project corridor. To support the effort, we developed 3 tools that are in use. Was deployed last June, July timeframe. We have a search tool, which allows users to basically upload a project corridor or draw one, and they can download any of the 700 layers that we reference down to their local drive to help them do the work locally on their desktop. We also provide a screening tool, which is a standardized screening of a project corridor, which allows the upload of a project corridor or once again a drawing or a buffering of an existing STIP project. And basically we have a common frame of reference so that when a project is starting to be talked about, like what is it going to impact and the different things we might encounter, that standardized screening allows people to work from a common frame of reference, which is very nice. And then finally, we have a workbench. So as the project enters project development and the engineering consultants and planners are working on projects and they're developing reports, not only the final environmental document, but all the documentation surrounding that final environmental document. Lots of maps are generated, lots of PDFs are generated with maps in them. We standardize that process and all the way down to the naming convention of the PDF files that are submitted, and also the data that we wanted to extract out of those standardized reports. So if you're going to be doing a wetland delineation, we have a very specific template for the wetland delineation file that you're supposed to submit, and we take that in, and then we are able to recycle that data back through to the next project that comes in that area. And we also can cycle that data over into environmental modeling work, which is done using some machine learning and artificial intelligence work, where if we've located a species or we haven't located a species within a corridor, we can pass that information through and let the model update itself so we can do better predictive modeling in the future as projects come through. So that's sort of what Project Atlas does. But one of the big problems we do have is when we don't have data. And what we'll do today is we'll discuss the importance of utilities data. And it's one of those challenges that best exemplifies where if we don't have good data early on in a process, especially with project development for a DOT, you can really run into problems accurately assessing the true cost of the project and time frame. So like we saw earlier, here's our project delivery timeline. But what's important to see is that down here in these boxes, you can see some timeframes called out. So early in prioritization and programming at NCDOT, that's when the initial budget is established. And that's really important because that's when the first look at how much a project's going to cost is basically put forward. There are a lot of like worst case scenario, feasibility design type things done to generate that number. But The utilities in this circumstances, we're using this as an example of utilities. Utilities aren't really heavily looked at that point. And then the project will move into a handoff between the prioritization and programming phase into project development. And that's really when the alignment starts to be defined and things like that. But utilities still aren't being located at that particular time. They are going to come in towards the end of that process prior to design, and utility coordination will start to occur at that point. Once it goes through the design process, we actually get into the part where the utilities will actually be engaged officially to move their facility. So if you have a water line that's within a right-of-way or a power line that needs to be moved, a lot of times the utilities aren't actually located until after project development is well on its way. And so if there's something major in the corridor that needs to be moved, if it wasn't inherently known by the project manager or the local team involved, you could incur a serious obstacle to getting a project completed on time, or it may be detrimental to the project budget. And so that's why when we are looking at project delivery with GIS engaged, the more data we have earlier in the process, back here in the prioritization and programming phase, or even back in the planning phase, like we were talking about earlier, they can make a much better judgment on what the project will encounter, how the budget will be impacted, and how the time frame will be impacted. As it stands now in a lot of DOTs, because of their relationships with the utilities, the actual engagement of the utility and actually getting folks out there to locate these utilities comes much later in the process, and it causes a lot of obstruction. And so to further exemplify this task, if you're looking at the utilities problem, in North Carolina, there's over 400 unique utility providers in this state, and they're provide a diverse amount of services. So water, electric, fiber, wastewater, comms, gas, all those things that you see listed here, they all can occur within the DOT right-of-way as a project is being proposed. A lot of the information that is out there for the public to consume is very sparse. So maybe we can say that better. There's not a lot of information out there for the DOT to consume. And there's also not a lot of data that's available just based on relationships. So what we have encountered within the DOT is that without that information being available, we end up with a lot of like gotcha moments on the project where we're like, oh my gosh, I didn't realize there was this electric line or this fiber line, or where'd that pump station come from? And so with a lot of providers, you have to have a lot of relationships. If we just look at power providers alone, there's 105 different power providers in the state. And we have our major ones like Duke and Dominion, but there's a lot of others, including electric membership corporations, municipalities, and schools and universities. And how this plays out spatially is you can see here that Duke and Dominion cover a tremendous amount of our state. They're the ones in green and red here. But all those other gray areas are where the other power providers exist. And each one of these providers has a GIS system that has spatial data located in it. But there's no relationship with the Department of Transportation right now to serve that data to us, even the corridor for where that data exists. Even if we had the corridor, that would be enough for the majority of the work we do. And so this information is not readily available and provided to us as part of the project development process. So if you were to look at the STIP, how that measures out, you can see a tremendous amount of projects don't occur within the STIP outside of those two major providers. So the pink here you see is Dominion and Duke. And so you have all these other projects in our STIP that are occurring outside of those two major providers. So even if we negotiated agreement with Duke and Dominion, we still would have to negotiate with those other remaining 398 providers to access that utilities data. Some of those conversations are occurring now, and we actually have a really good conversation going with Duke at the moment to get their corridor information to us so that we can do some better planning. But you can see that there's a lot of other places where that data is not being provided. So what does this actually look like in concrete project-specific occurrences? What you'll see here is a project that we have been working on recently, and it's a U3467. You can see here that the corridor study area is all that area in red. And we know, based on some analysis we've done, these are all the providers that are in that area, but we don't know exactly where they're at when the project starts off in that initial planning phase and also into prioritization and programming. And so if we were to use GIS data that's freely available in this particular corridor, what you'll see is this next line here, you can see there's just a red line that occurs on the right side and another red line that comes up. That's the only data that's publicly available for that corridor. If we zoom in, what I'll do is I'll show you how this plays out specific. You can see here, this is the center line of that road. And then we have that one line that comes through here, that's that transmission line. You can see the transmission tower here and the lines in the aerial photograph. But in reality, what it looks like on the ground is this. We have a whole series of utilities that are actually present on the ground. And they include water, gas, telephone, TV, electric distribution, and electric transmission. That was the one line we saw available there. And you can see over here on the right, the people who are involved range from Duke Energy to Conterra. So there's a whole variety of data of utility owners. And there's a variety of GIS data that could be provided to us early on if there were agreements established between these power providers or these utility providers, so that when the project was starting off early on in that planning phase, we would have a better idea of how to price that project and establish a timeline on it. Next is an additional look at another part of that corridor here at the end. This is a little bit farther along in the project as it was going on. You can see here that we can lay the design over top of that. So this is the new design. You can see that the road is being widened here in a couple of different places to accommodate this design. And you can see here the amount of utilities that are actually in that intersection and the amount of utility coordination work that'll have to happen in that world. So if you think about the job of a utility coordinator is a person who's in charge of communicating with all the different owners of all these different utilities in this particular area that are going to be affected by this road project. And so if a utility coordinator is appraised earlier on in the process of the people he is supposed to be contacting with, he can establish working relationships earlier in the process so that he can, in fact, gain their trust and help them to understand the project is moving forward and it's going to occur in this following manner. And that way, utility companies can agree earlier in the process to start the paperwork to move their utilities. And that way, that process won't be hung up on the realm of months and years. So once again, sort of looking at this time frame, what we're looking at is having this red line here that we have with where the utilities are located. That could move all the way back here into the #1 spot if utilities were willing to share data with us earlier on based on trust and relationships. And then when the utilities could actually engage, could move farther back in the process into the end of step 3, maybe into step 4, if we were able to really take advantage of the communication. Like we talked a little bit about, there's current costs for not knowing early enough. We can have recurring design divisions. It can design revisions. So we can end up having projects as late as the 25% plan submittal process have to be revised. And so if you think about that, as a project is taking shape, at 25%, you basically know what you're going to build. But if the utilities aren't have not been located correctly, or the relationships with the utility provider haven't been established in such a way, that can cause a tremendous amount of change to those plans. It can induce schedule delays on the scope of a month to a whole year. We've seen projects in DOT where a particular type of facility had to be actually picked up and moved, and the time it would take to construct the new facility is quite significant. And so if that relationship is established early on, it can really benefit that process. Budget increases, loss of trust. A lot of this comes down to trust between a utility provider and the DOT, and more communication and open interaction between the utility provider and the DOT will establish that trust earlier, and so allow things to basically move a little bit smoother. In order to kind of engage this process, we are trying a number of things to get GIS data into the system earlier on. We've contacted the 811 provider, which is sort of like the Miss Utility, or the before you dig, contact such and such. A lot of people have different names for it in different states. For us, it's mainly 811 is the term we use. And so what we do is we contacted the 811 organization. And because they have a unique MOA with each of the utility providers, they have all of their data in the system. But because the relationship that they have with the utility providers is unique to them, they cannot share the data with the DOT or anyone else. And so even though that data is out there and is being provided 2811, so that when you do submit a request over the internet, they can accurately tell you who's in the area and who they have to call, they can't share that with us, which was quite a disappointment. We contacted them via the DOT encroachments group within NCDOT, and they also failed. And so we looked for open source data with some limited success, depending on who would put stuff out there. We engaged a company called Maser Engineering. They had done some work for us, and they have a very, a very experienced staff with a lot of really good relationships within North Carolina. And they've been able to bring a couple of utilities to the table for us, including some of the interactions with Duke. They've also interacted with some of the smaller utilities, also interacted with a lot of the local providers, which includes municipals for like water and sewer and things like that. And we also engaged consultants from the administration's level, higher level type of companies such as KPMG, to go ahead and broker conversations with the utilities as well. A lot of that work was basically researching who had put data out there on the internet, who was willing to share. And so they have a matrix developed at this point of what the potential data acquisition task looks like. So there is some of that going on right now, but it's still extremely large challenge. But like I said, this data could serve all the different groups within our process in regards to the NRTR, not the NRTR, the different documents that are generated throughout the process. Just because of the fact that if there's going to be impact to the environment due to the moving of utilities, that could impact a lot of the other pieces of the project delivery process. Some of the thoughts we've had moving forward and the discussion points we've had to have with a lot of these utility providers is around security, especially being able to keep that data somewhat abstracted from the end user, security requirements regarding login, using specific security protocols regarding our state's NCID, which is like our universal identity store, but also the NCDOT's Active Directory account and having to organize that, set up on the backside at the NCDOT level and then at the statewide level. And also security around ArcGIS portal. We've had to encounter each one of those items in our conversations with folks so that they understand that the level of security around their data is quite high. And then if the utility provider is looking to share the data with us, understanding their security postures and preferences, which we don't know, each one of those 400 people is going to have a different opinion on the matter. And so we would have to consider that. And so that moves us over towards embracing web services as the solution that we put out there to a lot of these individuals. If they would be willing to serve their data via a secure portal, that would be much more advantageous to us coming from the DOT side. Now, obviously, knowing who we're dealing with, some folks can do this, some folks cannot do that. And so we're hoping to broker not only relationships for web services, but also submittals, either ones that we can go pick up, we can host on their behalf, things behind a security wall. All those things have to be considered as we're going through this activity. So if we were trying to move this forward from the DOT side, we can't do this by ourselves. We have to establish at the state level the importance of acquiring utility data. So we have a lot of people within the realms of the state agencies advocating for this on our behalf. So we have like our Geographic Information Coordinating Council, which is an organized body across all the different state agencies that use GIS. That group itself has actually made this one of their top priorities for the coming year, not only for DOT, but just for the surveying community in general and for a lot of other types of work. Building communication and trust with the utility owners. Crafting tactical relationships is also very important to getting GIS data into the system. Having people within your agency or your organization being willing to go out to lunch with utility providers and go out and play golf and establish these relationships where people understand the need on a personal level and how it will affect each of the individuals within the state by lowering the costs of projects that are being built and also speeding them along. And that's really what it comes down to, is people really need to understand on a personal level how important it is to get the GIS data available for people who are doing project planning. We're looking to construct some use cases and gathering feedback, and we're also they're also forming a committee at the state level to do this work. Much like there's an initiative for parcel mapping within our state, and we were able to develop a statewide parcel layer that's updated on a quarterly basis. We would love to have that type of initiative around utilities. And I know I'm using utilities as the prime example here, but this could be for any type of data set. And why the more of that standardized data we could get in and serve it earlier in the process would be extremely valuable. And then we'd also like to get a blanket MOA or MOU out there similar to 811, where we could come at all the different providers to have them share with us their data. But that's quite a challenge. And like I said, our relationship with the 811 group, while good in terms of socially interacting with them, in terms of actually getting under the hood and working with them on understanding how that data comes in and all that, that is very much an abstracted thing for us at the moment. Whoops. So at that point, that kind of takes me through what I had to present today. You're free to email any of the folks on this list about questions regarding how we're proceeding forward on this particular item. If you have questions about the Atlas application, you can email at the atlas.ncdot.gov. That'll make it over to me as well if you don't choose to email me directly. But we could share as part of that effort a number of the data sets that we use, and we can also share any of the details around what we're doing. So thank you.
Thank you, Eric. I'd like to open it up now to any questions. If you have any questions, just type them in the question bar or in the chat bar, and we'll let Eric field some questions about the Atlas application and the Atlas project, I mean. So I do have one question here. What is the current level of participation from utilities in Project Atlas? You mentioned there are a lot of utilities in the state. How many are in the project?
Right. So at this point, there's really only 4. 2 municipalities have offered up some of their data willingly. Some have data that's sitting out there that we can harvest via their published web service endpoint, but they aren't necessarily a willing participant. They're just an unknowing participant. So, and we have 1 power provider, and we do have a working relationship with Duke as well. So it's not very much, and we were hoping for a lot more.
Do you know why the utilities are opposed to sharing their data, or participating?
Right. I think that's one of the questions that we ask ourselves a lot, is why they wouldn't want to participate. And I think that a lot of it goes to the security question. Whenever we engage the conversation, they're willing to provide us small snippets of their system's data, such as, within our project corridor, maybe a couple miles worth of alignment. Some are willing to provide us the right of way within that area, so we can at least know they're there. But a lot of it revolves around security, and a lot of it revolves around liability. And so I understand that totally. I don't fault them necessarily for that approach. But one of the things that we are having a hard time with is even starting the conversation with them, just because of a lack of trust over the many, many years of project developments occurring, and due to lack of transparency in the process, there's a tremendous amount of unwillingness to move on inquiries about their utilities in a particular alignment, due to the fact that it may cause them undue burden and costs they have to fit into their budget.
Sounds frustrating.
Yes.
I'll give another minute for anyone to type another question in. Are there any more questions for Eric on the Atlas project? Again, his contact information and the rest of the his partners on this project will be posted with the presentation when we post those on the GoTug website after the webinar is finished. Give us a little while. It won't be immediate, but within the week, hopefully. And I guess we're going to turn it back over to Jeremy and let Jeremy take us through to the end. And don't forget to unmute yourself for your final
Right.
word.
I'd just like to thank everybody for coming to the webinar. Just a reminder, our next webinar for GIST presentations will be on September 2nd, 2020. So if you haven't already, sign up for our mailing list to be invited to that webinar. And I hope to see you soon. Thanks again, everybody. Have a good day.
All right, we'll see y'all in 3 months.
Thank you.